Welcome everyone. It is 3 p.m. and it's time for a server room show. This is episode 40. Today we will talk about continuous configuration automation tools, CCA, and exactly we're gonna talk about Ansible. So I hope that my all-time listeners and fans, 2 humans and a black cat named Ben, are ready, so we can start this. I raised the volume on the audio in for the ones who watch this on twitch.tv because they always mention that the audio volume was low there. So I raised it up a little bit. I don't know what 4 decibel would mean compared to 0. So I expect it's at least louder and better than normally. So Ansible and all these continuous configuration automation tools, why they are important amongst with other tools in sysadmins or DevOps arsenal. They are important because tools like Ansible or PowerShell, we will talk about PowerShell at some point. I will make an episode on it. These tools are making us more efficient. We can be able to manage bigger infrastructures. We can do things which otherwise would take us, I don't know, let's say half an hour. We can achieve it in 4 minutes. We can administer and make sure that the things we do are consistent throughout. Imagine if you need to apply, let's say you need to make sure that 2 simple settings are set exactly the same throughout, let's say 50 servers. How you make sure that there is no human error, or you don't miss one of them, or you don't change on one of them only one of the settings instead of both of them. So tools like this continuous configuration automation tools like Ansible I'm gonna talk about are great for automating these kind of tasks. We need to know what is infrastructure as a code. Infrastructure as a code is the process of managing and provisioning computer data centers through machine-readable definition files, rather than, as I mentioned, doing those physical hardware configuration changes or using these interactive configuration tools, in layman terms, the GUI interfaces. So instead of going through the manual labor of physically changing something, or diving through sub-menus in somewhere in the GUI on control panel or whatnot, it's more efficient and quicker to use some kind of machine-readable definition file. So we can make the computer do these desired changes on the state of the configuration. The IT infrastructure managed by this process comprises both physical equipment such as bare metal servers, as well as virtual machines and associated configuration resources. The definitions may be in a version control system. It can use either scripts or declarative definitions rather than manual process, but the term is more often used to promote declarative approaches. There are 2 main type of approaches. One called declarative, functional, and another one is called imperative, procedural. The difference between the 2 and what makes you understand it much more simple and much better than how they are named and called, these 2 approaches, is that one can be described with the word what, and another one can be described with the word how. So that's how these two approaches, declarative and imperative, differs from one another. One is describing the what, and another one describing the how. The declarative approach focuses on what the eventual target configuration should be, and the imperative focuses on how the infrastructure is to be changed to meet this desired configuration. So the declarative says, I want it to look like this, while the imperative says, how can I, what are the steps required to achieve configuration X I want to achieve. The declarative approach defines this desired state, and the system executes what needs to happen to achieve that desired state, while the imperative defines specific commands that need to be executed in the appropriate order to end with the desired conclusion or configuration. To do this, there are two methods used or applied. One of them is the push method, and another one is the pull method. The main difference is the manner in which the servers are told how to be configured. In the pull method, the servers to be configured will pull its configuration from the controlling server. In the push method, the controlling server pushes the configuration to the destination system. The pull continuous configuration automation tools which are using the pull method, for example, Chef or Puppet or CF Engine, they always, nearly always, they require an agent or a kind of agent being present on the client machine or on the machines you desire to control or to do this automation on. While the push methods, they can do the same thing the other tools do, but without using any agent. And the reason being that for the pull method, the clients each time in a given frequency, with a given frequency, they have to check in, so to say, with the management server where the automation tool is hosted, and ask, is there anything new for me? Is there something you want me to do? And that's what the agent sitting there on these clients with the pull method, taking care of that this communication happens every so often. While the push method can be agentless, as the initiation of a desired action always happens and initiates from the server and from where the continuous configuration automation tool is hosted or being placed. And for some people it can be a deal breaker, having or not a configuration agent always present or not. It definitely can have pros and cons between push and pull methods. I didn't dive into the differences or which one is better, as I focus mainly on Ansible in this episode. As I mentioned, some examples which probably you know, like Chef, Otter, Puppet, SaltStack, CF Engine, Terraform, and of course Ansible. Ansible, you probably heard about it or already know that Ansible exists as a form of a corporate offering from Red Hat, because Red Hat purchased Ansible a couple of years back. And what Ansible Tower is, don't think that it's it's something completely different, or that there is something you cannot do with Ansible, the free and open it is. Ansible Tower pretty much is just a graphical user interface, so you can easily create what is called playbooks for Ansible, which you will see one of the building blocks for working with Ansible, where you actually write out in a language pretty much similar to human language, but in the case of Ansible Tower, you can use kind of like a graphical user interface. I even placed a photo that it's I'm not saying it's very nice and fancy, but you can do exactly the same and achieve exactly the same using the command line and using pretty much the only thing you need to work with Ansible, which is a text editor. So people who feel the need that they need to have some kind of a graphical user interface to build these Ansible playbooks easier, they are in luck, because an open source offering exists pretty much similar or mimicking Red Hat's Ansible Tower, called Semaphore. But for real hardcore people, they probably stick with Ansible as it is, and with their favorite text editor. I lost my line there, was I? To be able to continue with Ansible, we have to see very briefly what is DevOps. DevOps is a set of practices that combine software development in the acronym Dev with and IT operations, which is the Ops. It aims to shorten the system development lifecycle and provide continuous delivery with high software quality. DevOps is complementary with Agile software development. Several DevOps aspects came from Agile methodology. CCA Tools relationships to DevOps. Infrastructure as a code can be a key attribute of enabling best practices in DevOps. Developers become more involved in defining configuration, and Ops teams get involved earlier in the development process. Tools that utilize infrastructure as a code bring visibility to the state and configuration of servers, and ultimately provide the visibility to users within the enterprise, aiming to bring teams together to maximize their efforts. Automation in general aims to take the confusion and error-prone aspect of manual processes and make it more efficient and productive, allowing for better software and applications to be created with flexibility, less downtime, and an overall cost-effective way for the company. Infrastructure as a code is intended to reduce the complexity that kills efficiency out of manual configuration. Automation and collaboration are considered central points in DevOps. Infrastructure automation tools are often included as components of a DevOps toolchain. What the main takeaway could be from this? Maybe it doesn't explain in clear terms, but these automation tools, while they are great asset for developers, they are just as great for operations engineers, like system administrators, like I described in the beginning, that if there is a tool out there which is thanks to its easily readable and learnable, does the word exist? The reason that it's also very easy to learn, to handle, because normally sysadmin people, at least people like me, I mean, the moment I need to write, not even go as far as code, but go as far as script, like Bash or PowerShell, I immediately don't feel as comfortable as with any other operation. I don't know why is that. So what I'm trying to say that when there is a tool which is very easy to learn and handle, thanks to its nature, that it's very similar to nearly spoken English, and it's easy to read and describe what you want the tool to do. Then if someone like a sysadmin can choose to do, like in the example, manually configure those two settings on 50 of its servers, he has to do and spend let's spend 1 hour to make sure that on 50 servers, all these things are done and changed. I know he could probably use PowerShell or some other script, but imagine he's introduced to tools like Ansible, and then he say, okay, so I either spend 1 hour here and do this thing I have to do manually, or I create a playbook in Ansible for whatever whatever I need to change on all these 50 servers, and it's done in 5 minutes or even less, and I go have lunch 55 minutes earlier than I would do naturally if I have to do this with hand. So that's how it is useful and beneficial for not just for developers, but for IT admins and IT technicians like ourselves. So what is Ansible? Ansible is an open source software provisioning, configuration management, and application deployment tool enabling infrastructure as a code. It runs on many Unix-like systems and can configure both Unix-like systems as well as Microsoft Windows. However, I would point out that one of the reasons why I want to talk about PowerShell in a later episode, that I think that for certain scenarios, perhaps I would stick to Ansible when it comes to Unix-like system to be managed, and I would keep PowerShell and perhaps some other tool when it comes to administering a Windows server. It includes its own declarative language to describe system configuration. Ansible was written by Michael Dehan and acquired by Red Hat in 2015. As I stated previously, that Red Hat bought Ansible a couple of years ago. Ansible is agentless, temporarily connecting remotely via SSH or Windows Remote Management, allowing remote PowerShell execution to do its tasks. The term Ansible was coined by Ursula K. Le Guin in her 1966 novel Rockenon's Word and refers to fictional instantaneous communication system. I left this in because I found this interesting. The Ansible tool was developed by Michael Dehan, the author of the provisioning server application Cobbler and co-author of the Fedora Unified Network Controller framework for remote administration. Ansible was the company set up to commercially support and sponsor Ansible. Red Hat acquired Ansible in October 2015. Ansible is included as part of the Fedora distribution of Linux owned by Red Hat, and is also available for Red Hat Enterprise Linux, CentOS, OpenSUSE, SUSE Linux Enterprise, Debian, Ubuntu, Scientific Linux, and Oracle Linux if someone uses that. I don't really think so. We don't really like Oracle. We have extra packages for Enterprise Linux as well as for other operating systems. Unlike most configuration management software, Ansible does not require a single controlling machine where orchestration begins. Ansible works against multiple systems in your infrastructure by selecting portions of Ansible's inventory stored as editable and versionable ASCII text files. Not only is this inventory configurable, but you can also use multiple inventory files at the same time and pull inventory from dynamic or cloud sources or different formats like YAML and inifies and so on. Any machine with Ansible utilities installed can leverage a set of files directories to orchestrate other nodes. The absence of a central server requirement greatly simplifies disaster recovery planning. Nodes are managed by this controlling machine, typically over SSH. The controlling machine describes the location of nodes through its inventory. Sensitive data can be stored in encrypted files using Ansible Vault since 2014. In contrast with other popular configuration management software such as Chef, Puppet, and CF Engine, Ansible uses an agentless architecture with Ansible software not normally running or even installed on the controlled node. Instead, Ansible orchestrates a node by installing and running modules on the node temporarily via SSH. For the duration of the orchestration task, a process running the module communicates with the controlling machine with a JSON-based protocol via its standard input and output. When Ansible is not managing a node, it does not consume resources on the node because no daemons are executing or no software installed or no agent is running, as we discussed. The design goals of Ansible include to be minimal in nature. Management systems should not impose additional dependencies on the environment. To be consistent with Ansible, one should be able to create consistent environments. Like we mentioned in the example, that if we want an environment where the same settings set the same way throughout our machines, using a tool like Ansible can help us completely eradicate the chance for human error by doing this task manually. It has to be in the design goals. It mentions it has to be secure. Ansible does not deploy agents to nodes. Only OpenSSH and Python are required on the managed nodes to be able to be managed with Ansible. Highly reliable. When carefully written, an Ansible playbook can be idempotent it is, to prevent unexpected side effects on the managed systems. It is entirely possible to have a poorly written playbook that is not idempotent. Minimal learning required. Playbooks use an easy and descriptive language based on YAML and Jinja templates. As I said, that's very attractive for people less familiar or people who get easily scared when they need to write even a single script or let alone program something. Modules are mostly standalone and can be written in a standard scripting language such as Python, Perl, Ruby, Bash, and so on. One of the guiding properties of modules is idempotency, which means that even if an operation is repeated multiple times, for example upon recovery from an outage, it will always place the system into the same state. Inventory configuration. The inventory is a description of the nodes that can be accessed by Ansible. By default, the inventory is described by a configuration file in your YAML format, whose default location is in /etc/ansible/hosts. The configuration file lists either the IP addresses or host name of each node that is accessible by Ansible. In addition, nodes can be assigned to groups. Ansible pretty much has two building blocks which it uses to function and do its job. One is the inventory configuration file, which keeps and holds all the hosts either described by their IP addresses or host names, and either being individual nodes or grouped together as the ones you see people who follow my videocast can see my screen right now, or the ones who look into the show notes, you can group nodes together. For example, you can refer to a group of nodes as web servers, and all the ones listed below in this group can be later be actioned as part of a group. You could send an Ansible playbook to the group of web servers, just as you would be able to send an Ansible playbook to an individual node itself. So this file is one of the main building block of Ansible, and another file is the one we already mentioned, the playbook file, which describes in a very simple and easily a language which can be easily learned, describes the actions which needs to be taken, your desired actions you want to take on the node. And in this example, you see on the screen there, you have 3 nodes, and one of them is an individual node described as its IP address, and there is 2 nodes, refer to them with their host names, grouped together under the common group called web servers. Ansible can also use a custom dynamic inventory script, which can dynamically pull data from a different system and supports groups of groups. Playbooks, the second building block which Ansible needs for functioning. Playbooks are YAML files that express configurations, deployment, and orchestration in Ansible and allow Ansible to perform operations on managed nodes. Each playbook maps a group of hosts to a set of roles. Each role is represented by calls to Ansible task. On the screen you can see I have a very simple example which being actioned in a group of hosts referred to as web servers. It uses 2 simple variables. One's called HTTP port, which indicates the number, the port 80, and the maximum number of clients 200. It is being executed with super user privileges. It will need root privileges on the client's end to the actions following to take part, and then it breaks it down to simple tasks. You can have multiple tasks and also multiple steps in a task. This playbook, for example, first it makes sure that your Apache HTTPD on this server, on the web servers, are the latest. Then it writes the HTTPD configuration file. Then it does a restart, notifies and does a restart of the Apache server. Then it makes sure that it started back, and that's pretty much it. What it does in this example. Ansible Tower, as I mentioned, is a REST API web service and web-based console designed to make Ansible more usable for IT teams with members of different technical proficiencies and skill sets, people like me. It is a hub for automation tasks. Tower is a commercial product supported by Red Hat, derived from AWX upstream project, which is open source since September 2017. And as I mentioned, there is another open source alternative to Tower, which is Semaphore. And the rest is the links to this article. As always, we had 30 seconds left on the clock. I hope you guys enjoyed, and we will see each other next Saturday again. Have a nice weekend.